Hello guys, welcome back to my YouTube channel and today we will be learning about the applications of finite automata and networking. So, um, let us first start with finite automata and what are they? They are basically divided into two different subcategories, DFAs and NFAs. Your DFAs are basically where each state takes only a single out input and gives out a single output, whereas your NFAs has several possible outputs, like several possible structures. This structured approach to managing sequence makes finite automata a natural fit for networking, where strict states and transitions are key to handling data over changes. Okay. So, at its net overview of networking, at its core, networking is all about data exchange between different systems. Some primary functions of networking includes protocol design, error detection, data routing, state transition, etc., etc. So that's all. Now, finite automata and networking requires protocols. In network protocols, especially the more complex ones, there are multiple states that the system needs to manage. Take TCP, for example, where we had an example for TCP. You can find it. Well, anyway, it will appear eventually. So basically, take TCP for example, it has states like SYN, ACK, FIN. They are this basically means synchronize, acknowledgement, finish. And these finite automata help us to make these states. Then the transition between them, such as SYN to SYN ACK, which is essential for establishing connections using automata and protocol design makes it easier to visualize and manage these states for a more reliable communication flow. Now, for protocol verification, pardon, protocol verification, finite automata and particularly DFAs are invaluable tools for verifying and the correctness of the protocol by simulating all possible protocol states and transition of automata can catch issues early on. Some benefits include reliability, predictability, robustness, the IDS. Okay. Uh, Now, in network security, finite automata can detect patterns that indicate potential malicious activities. An example of an IDS system can be used to use we can use automata to recognize certain action sequences or behavioral pattern associated with threats by like malwares or other kinds of viruses which can hack into a network security, weakening its strength. Now, traffic analysis. There also, yeah, here there's a slide for TCP. Now, for traffic analysis, and finite automatas are like a really valuable asset. Like they can, they help in analyzing network traffic by categorizing the data packets into patterns. Example, automata can modify sequence and data packets to identify and classify traffic types such as web traffic, streaming data, malicious packets. This classification is crucial for improving both network performance and security by enabling administrators to better understand, manage and traffic the flow. Pardon. Um, Regular expression matching in networking is also like a crucial role for the finite automators. Uh, Regular expressions are heavily used in networking and for searching and matching data packets in different patterns. Example of them is data filtering and inspection. They often rely on automators to perform them quickly. Packet filtering in firewalls is also one of the key roles these automata plays in networking, like finite automata streamlining packets, filtering by matching packet headers against a set of predefined rules. Advantages include effici um, efficiency. Automata can quickly process fields within the packet header, allowing or blocking packets based on these matches. Consistency. This ensures a uniform approach to handling data packets, which is essential for maintaining security by preventing unauthorized access. Uh, Now, we will, one second. Uh, Now, we will learn about session management in protocols. In session-based communication, finite automata help manage session states across life cycle of a connection. Like finite automata track state transition in sessions from establishment to maintain the closure. This state track supports session integrity, making sure that communication remains orderly and resource usage is optimized. Routing algorithms, finite automata model decision-making process in routing protocols by representing route paths and condition as states. Example, like BGP, border gateway protocols, automata-based model support path section based on network conditions, leading to more efficient pathfinding and improvement of data routing. Data compression, yeah, now that's a good one. Finite automatas assist in identifying recurring pattern, which is essential for data compression, application, and networking. Infinite, but we will name a few. Compression, compression of algorithm using automata to for a repeating sequence in data, which allows for efficient encoding and transmission. This process is beneficial in reducing bandwidth usage and storage requirements. Error detections and correction mechanisms. We all know about CRC and FECs. We have given like a brief on all of them. They are basically used to leverage finite automata to verify data integrity. For example, let's take CRC. CRC uses finite automata to detect errors during data transmission. If a sequence doesn't match expected pattern, the automata flags the data, prompting a resubmission to ensure reliability. Now, we have a few more one more point. Finite automata and load balancing. In load balancing, finite automata tracks server states to distribute traffic efficiently. Outcome by monitoring state like idle, busy, overloaded. Automata supports efficient traffic distribution across servers, enhancing redistributiveness and balancing workloads. In conclusion, automata plays an in conclusion, finite automata plays an essential role in various networking tasks, from protocol verification uh, from huh, to handle more sophisticated tasks, including dynamic load balancing, uh, advanced intrusion detection, and AI-driven routes. Now, at the end, I would just like to thank you for watching the entire video, and if possible, do like, share, and comment. Thank you.